Hey everyone, welcome to this talk on MLOps. My name is Chris Noring, I'm from Microsoft. This is the table of content for this talk for the next 40 or so minutes. We'll talk about three major things. So one is try to define what MLOps is and what kind of the expectations are of MLOps. Then we'll go into chapter 2. We'll cover how you will take your normal notebook and put that in the cloud using a service called Azure ML. And lastly, we'll talk about the automation piece, where we're going to use GitHub and GitHub Actions to get us there. So warm welcome to this talk, and I hope it's going to be interesting for all of you listening. So first, let's try to define what things are. What is MLOps? MLOps can be said to be the following. It is a set of practices that aims to deploy, maintain machine learning models in production reliably and efficiently. So now we kind of established the goal here, right? We're saying that we have a machine learning model. It needs to be put into production in a reliable way and also in an efficient way, because all of this is about speed and precision. There are a few people involved as part of this process. First off, we have the different actors. We have data scientists, we have DevOps engineers, we have machine learning engineers, and all of them come together. As you can see here on the top right of this slide, there are three different circles, one representing machine learning, the other one DevOps, and then data engineering. And you see the intersection of all three then becomes MLOps. So it's all about devising that algorithm that ends up being a machine learning model and put that into production. So there are some overarching high-level goals that you want to fulfill as part of MLOps to really ensure that whatever you do around MLOps is worth the effort. Because number one goal here is that you want to increase automation. That means that you can deploy things faster if you've automated all the different steps, from writing a piece of Python code to building the model to do whatever you need to do, maybe fetch data as part of your bigger process. All of that needs to go faster so that you can deploy faster, which means time to market will be even faster. And the winner is, of course, your customers. Then you also want to ensure that you can improve the quality of your production models, because you might not get it right on the first attempt of creating that model. So you want to have a system that you can oversee, in which you can improve the model and bring also that increment into production. And you also need to focus on specific requirements. Those requirements can either come from business or they can be there in place because of regulatory issues. So definitely don't forget about that, because that's your bread and butter as part of you as a company. Now, there are a few different things to consider, especially around lifecycle management. Of course, the biggest piece here, the first piece, is about model generation. That's the core of your business, the thing that's able to predict what you needed to predict or what have you in terms of goals for your created model. And then, of course, we have the orchestration and deployment. How to orchestrate all these various bits is not as simple as creating a notebook. We all know that. We need to fetch the data, we need to clean the data, we need to build features, build the model, and then get it out. So you can just imagine all of these various steps as part of a bigger whole, as part of your entire company, needs to be orchestrated so that everything leads to production sooner or later. And then, of course, health is an important component as well as part of all this. You need to make sure that your model is healthy. The application that consumes your model needs to be healthy, because ultimately there's an end user or an end system that will consume it. And then, of course, you need to focus on diagnostics. Do you understand what things you are measuring to ensure health? Are there various ways of troubleshooting if something goes wrong? And then you got the governance piece. You need to make sure that you are abiding by all the different rules and regulations set out by your business, set out by the larger domain that you work in. This is especially important if you're working towards a government or if you're working towards a larger enterprise or just generally. And then, of course, comes the business metrics that only your specific company knows about, or within the domain that your company is acting in. Those are metrics that you also need to ensure that in terms of your application and your model. Now, when it comes to MLOps and specific goals, you can have another set of goals additional to the 3 major goals that I mentioned so far. So you could, for example, ensure that you have goals for deployment and automation. Also, you can have goals regarding reproducibility of models and prediction to make sure that you actually keep getting the same values or better values. You shouldn't regress, you shouldn't go to worse state. And of course, you can have specific goals towards scalability. Can you scale up this operation so that you can serve 100,000 customers instead of 50,000? You can also set out various goals around collaboration. And as you can see, there are quite a few different goals within different areas that you can set up. So please treat this as a checklist. Do we want to have goals within these various areas to make sure that our MLOps operation behaves the way it should? Now, looking at this from an architecture standpoint, that's always good to do, like a mile-high view of our operation. What are we trying to do? So most likely you have a data science platform. You are constructing the models within that platform. You might have subdivided other areas of this into an analytical engine where all your computations are performed. And then, of course, you got MLOps as the glue that binds to make sure that your ML models, the data, and all these outcomes between systems are able to interconnect, which eventually will lead you to production. Now, looking at various capabilities. So again, see this as a checklist. Think of whatever chosen software you go with, whether it is AutoML or Azure or whatever cloud provider. Make sure that all of these features are something that's part of that platform. So you should be able to create some kind of pipeline so that your model or your data is able to flow through it. You should be able to create various software environments. You know this by now. When you are creating something that's big, you should probably have a developer environment, some kind of testing environment, for example, a staging environment, but you should also have a production environment, of course. So by separating yourself in various environments, you mitigate the risks that could follow from you just going straight to production. And of course, we need to consider this model of yours. How are you going to register it? How are you going to package it? Is this a container, for example, or does your model come with other files, manifest files, and so on? And are you able to deploy your model from anywhere? And then you have the governance piece where you need to consider how you can capture governance data so that you can ensure that you stay compliant. You should also be able to be notified and alerted on various important events as part of your machine learning lifecycle. If that can happen, is the right person being sent an email or maybe there's a notification created within the system, so you have full control and full visibility on how things are going. And then, of course, monitoring is an important aspect of all this. Can you monitor your machine learning operations in production or in various other environments? And do you understand various issues as they arise? And are you able to take appropriate measures? And then, of course, which we will focus on half this talk on, are you able to automate? Are you able to not do a lot of these steps manually, because that will take you a lot of time? Are you able to kick off various automated processes to ensure that when you build a model or you change the model or you change an app, there is a process that kicks off that's able to ensure that this increment of yours can end up in production in a safe and reliable way? Now, in the second chapter of our presentation, we'll focus a bit more hands-on. Now we've kind of laid the foundation, what MLOps is, things to be concerned about on a high level, features our chosen system should have, and so on. So now you have a understanding of how you could be planning for MLOps, but how do you actually do it? Well, we will use a product here called Azure ML. This will not include automation in this chapter. You'll see that in the chapter after this one, but at least you get a sense of how can I take my old notebook and put that into the cloud so that a client or some other system is able to consume the work that I've done to create my model. So we will take our notebook, we will put that in the cloud, and let's get ourselves there. So let's focus on our scenario. So first off, here's a scenario. Your role is that of a machine learning engineer at a company. You are providing healthcare, and you've built a model to give you various insights on your core business. There's also this model in particular, very, very common scenario. You're able to predict whether someone has diabetes or not based on a set of metrics that you're looking on. That's all great, right? That's in your notebook though, so it's not really consumable by other apps or end users, maybe doctors or nurses or whoever might benefit from using this model. So what do? Well, we're going to take our notebook. We're going to turn that into Python code, and we will put it in production so that you can actually see it. But the question is how? Well, to get there, we need to understand that there are some concepts once we have chosen our cloud service. Concepts might be different on different cloud services, but for the chosen one, for Azure ML, there is such a notion of a job. So a job is essentially you taking your notebook, run the scripts that are within it, which produces a model, and make sure that that job is kicked off. So we will convert our notebook to scripts. We will define some kind of YAML configuration so that we can define a command or a pipeline job. And once we're done with everything, you will see how we can be using a CLI to help us with all of this. But for now, we will just do a visual presentation so you see what it's like to be just you on the team being a sole machine learning engineer. But that will take you far. Unless you are in a very big company, this will still take you far. So how do we do this? Well, as with everything in the cloud, there's kind of a two-parter here, right? Part one is to make sure that you can put your cloud resources in the cloud. Part one is making sure that you can create the cloud resources you need. So once you have the cloud resources created in the cloud, what you want to do is then to deploy towards these cloud resources, and then you will get that endpoint that you want. Right, so now with our pre-step, let's actually create these cloud resources. So how do we do this? Well, there are a couple of concepts that we need to know because we're using Azure ML specifically. One of these concepts is the notion of creating a workspace. The workspace is where you view and manage all your artifacts. This is very specific for Azure ML. You just need one of them, right? This is a one-off in many cases. Then you also need to create something called a compute instance. So this is a pre-configured cloud computing resource. And thanks to this instance, you're able to train, to automate, to manage, and to track machine learning models. So looking at this, what are we saying here? So this is Azure Machine Learning Studio. This is your visual tool to get things done. I don't urge you to follow along with me when I do this, but please just know that the first step is to make sure that you have an Azure account. Once you have that, then sign into ml.azure.com, and then you elect to create a workspace. Remember, this is a one-off. And then you need to fill in a few credentials here, like workspace name, your chosen subscription, your research group, your logical bucket where this lives, and your region. So please select a region that's close to you. And this is the interface. This is the studio. And what I've done first here is to just click on the new button. Once I click the new button, I'm faced with this modal, as you see, that says create new workspace. So that's all good, right? But how does this work? Let me show you a demo how this works. So now we're inside the Machine Learning Studio. Great. See if we can kick it off. So I should be creating a new workspace here by hitting the new button. And once I hit the new button, I can enter my workspace name. You choose what to call this. I can call it Oxford MLOps or Chris's MLOps, whatever. I choose a subscription and I choose a logical bucket, a resource group, or I could be creating an entirely new one. So I'm gonna elect to do that. So here I'm creating this, and I'm also choosing a region that's close to me. Once I do that, it will validate my input, and once it's done, it will have created that workspace. So as you can see, the provisioning is in progress, and once that's done, I'm able to kick off with the other parts of all this. Now, okay, great. So we have a workspace. What's next? Well, we need a compute instance because if you remember what I said earlier, we need to be able to train our model. So this is also an essential piece. Again, this is something you don't need to create a ton of times, but it's a one-off. So we will create this compute instance next. Right, so now we have our workspace that we created since before. So we can click into it so we can see our workspace, what it looks like, and you can see quite a few things here on the left side of things. You see notebooks, you see designer, components, pipelines, and much else. That's just if you want to give us some kind of thumbs up. But yeah, you need the compute, and you can click to create the compute. You can give it a suitable name so you know what it is. But the idea with this compute is that if you want it to be really performant, you will give it a lot of cores, a lot of ROMs and so on. But if you're fine with this, taking some time to train your model, that's also good. So I'm going to go with the standard selection. You can also see on the right side here how there's a different cost associated depending which compute you are choosing. So now I've chosen a compute, and all I need to do is hit the create button and then wait a couple of minutes. So grab a coffee, grab a tea, and just wait for that to be created. But again, this is just a one-off, but this is setting us up so that we can keep on working with this program. Okay then, so now we have actually created our workspace. We have created our compute instance. So what's next? Well, we haven't really touched the notebook that we have stored locally on our computer system, and we'd rather be able to do that. But to save some time, we will use one of those sample notebooks that are in Azure ML, but I will call out though throughout what we are trying to do so that you can take your notebook and adopt it to fit. So all you need to do is to combine your notebook and then do a few calls so that it creates a job from whatever you're trying to do. Now, what you're looking at here, I just wanted to show you the user interface beforehand, is that you will have a directory, you will have a subscription, you will have a workspace because we created that, and there's various bits of information that you need to fill in. The good news is that if you go to the top right of your visual interface, you can get all this information and copy paste it into the Python code that you see here. So how can we be creating a notebook? Well, as I said, you could bring your own notebook, or you can create or use one of these sample notebooks. I recommend when you start out with Azure ML to get a sense of how things work, please use the sample notebook. It's just going to make your life easier. So what do we do here? What are we looking at here is first off our workspace, and then we're looking at our compute because we brought up the compute interface. And you see that it's running. There's a green symbol that indicates that it's running, and that's great. So that means that we can now feed it a notebook that will do things and hopefully create a model from it. So now if we go into our compute, or rather we go into our notebook, and let's grab one of those samples. We go in here, we select a samples from the tutorial directory. We take this one, the getting started, and we could choose to clone this notebook. That means it's going to be copied into our user directory, so we can keep working on it from there. But this will take us through all the steps that you are likely to go through as you go from notebook to deployed endpoint. But start with cloning the notebook because that puts you in a good place. This should only take a couple of seconds. Once it's done cloning, then we can just run this cell by cell like you're used to. So imagine now that this is your notebook and we are just going through various steps. You can see here how this is going to train in a classification model. So the first step here is to connect to your workspace. As I said, when you try to connect towards the workspace. Okay, great. So we have cloned a notebook, and that means we are ready to run through each and every cells of that notebook. So we kind of put ourselves in a place where our notebook has made it into the cloud, but we haven't really trained the model yet. We haven't deployed anything. So let's do that next. So we will connect our Python code by adding Azure credentials. So we'll see how we can do that throughout this demo. We go through this demo, we go through all these various bits, and you see subscription ID, resource group name, and workspace name is something that it wants from us. So we can just copy these one by one and paste them. And once you pasted them, you can easily verify that things are correct by running the cell. So right now we're just doing a copy paste exercise, but hopefully you'll see, where do I get these credentials? How can I connect? And I need to connect to make sure that it understands towards which Azure resource am I actually going to do this model training. So now we pasted all the relevant information for it to be able to connect. So I hit play like I'm used to with notebooks, and it gives me a green checkbox. Fantastic. We've already created the compute. We don't need to do that, but now we need to think about the job environment. And here, what we're doing here is, and if we just, right, so now we're just setting up various different directories. So we're setting up a source directory, and now we come to a step. This is the main part of the script. So this helps us with various arguments. So now we're just scrolling through everything, and you can see at the end here how we're talking to sklearn to be creating our own model. And we could be configuring a bunch of different pieces. And let's also review our compute instance. We see that that thing is running, but we need to use its name. So it's using the correct compute. If we're not inputting the correct compute, it doesn't know which compute to use to train it, and this step will fail. So now by running this step, it's effectively training our model. And the very last step to do here, which we'll do in another demo, is to submit everything as a job, because then we will have the availability to expose this as an endpoint. So great. We have done a lot of things, honestly, in this last demo, because we're able to take our notebook and we trained it. So now that we should have some kind of model increment, but we haven't connected that to a job, and a job is a concept within Azure ML. So now we will do this next step, which will take 2 to 3 minutes to run. So this is when we are calling this client instance, create or update with a job, which means that it will be then available to Azure ML for us to expose towards the web. Right, so once we've gone through this step, we want to make sure that we can continue. So now we're going to submit the job. So let's see if we can do that. So we have called create or update, which means that we're now going into the jobs menu option on the left side. We see that the job is done. So we've kind of been a good TV chef here, because we've run the job step. And let's just review the different steps that remains, which is to deploy the model as an online endpoint. The job exists as an instance, as I said. So we need to be creating an endpoint like this. So we hit the create, and we can select the job, or rather the model that was created because of the job. And now we can just go through all of these steps and hit the deploy button. Now we just need to sit tight a few minutes. So once this deployment is being created, we just have to go and do something else. But this is fairly fast. You are really getting to the cloud in a matter of minutes if you know what buttons to click in what order. So yeah, we're just waiting for deploy to happen. You can go to this deploy, the endpoint dialog, and you can see its status is creating. You see this provisioning state here. And yeah, it's going to sit like that a few minutes. And you can also verify various authentication types. For example, you can use keys to access your service from the outside if you don't use it via this web interface. Still says creating, so we'll come back in another demo so you can see how that would work. Now, of course, we just assume that everything will be fine at this point, right? That the endpoint will be created. So the idea now for our next scenario is that we want to give this created endpoint some sample data. From that sample data, we will want to get some kind of response back. If we get the response, we know that everything is okay and that everything works. So, final step, right? We have created the endpoint. What you're seeing here is that the provisioning state is succeeded, which is great. That means that it's ready to be tested. So if we go into our test dialog, we can see how the input, what it can look like. But the input that we're interested in actually lives in our notebook. And you see that there's also consumption, so it can expose its primary and secondary key if you want to use this from a Python app. And you can also see how it's written code in both JavaScript, Python, C# or R. So you can just choose what kind of client code that you want to run for this. But as I said, the test tab is where you want to be, but we don't really have the test data. So let's go back to our notebook because it contains the sample data at the very bottom, I believe, of this example. So if you go in here, scroll a little bit, scroll some more. And at the very last step, there should be some sample data. Let's just copy this. Great. And let's return back to our endpoint for testing. Where's the endpoint? There we have it. So now we just go in here into the input and remove this stuff. There we go, and paste all these things, and we hit test. And now we are actually getting some output back. So that means our model is working, our web endpoint is working, and this is how easy it can be to take your notebook to the cloud, to a web endpoint, so now that any kind of client out there can interact with it. This didn't contain automation though, so that's our final chapter of this presentation today, but at least you saw how we can cloudify things. So we put the notebook in the cloud. What if multiple people are going to work on this? Well, the answer is really that we should be using something like GitHub and GitHub Actions to work with code and make sure that we can set up our CI/CD pipelines. Right, so let's talk about automation with GitHub Actions. The idea with automation is that we want to automatically execute a workflow that gives us that automated training and retraining. We want to make sure that also it's easy to train, to test and deploy. And for that, we've chosen GitHub Actions. There are many different systems that you could be using out there. But the idea for all of this to work is that we need to use a GitHub repo. The GitHub repo has something called GitHub secrets. In those secrets, we need to populate those with our Azure credentials that you before saw as in the visual indicator. For all of this to work though, for GitHub Actions to work, we need to be defining workflow files in a language called YAML. So, general automation, right? So let's take this through two different parts. If you never heard about GitHub and Git before or GitHub Actions, I think it's important to kind of lay the foundations. And then in the part 2, let's talk about how you actually do this with Azure ML, because it's two different discussions. First off, GitHub Actions. Let's set some foundations. Well, the idea with GitHub Actions is that things are running as the result of an event that happened, and then the runner is able to run a job, and each job is able to run n number of steps. So you can just imagine that this becomes a pipeline that kicks off a lot of things, everything from building the model to testing the model to deploying cloud resources and so on. So we want to be creating continuous integration, continuous delivery, so-called CI/CD. And we want to make sure that things are event-driven. So either we manually kick off a job, or it happens because we create a pull request, or because we merge code, or what have you. So just remember that we are still talking about the concept jobs. We are letting runners do their bit, but the really important part is to understand that these things happen for a reason. That's why we're putting event first, because without us defining when this happens, nothing will be run. So, a GitHub action, right? So, if you ever worked with GitHub repos before, you know you have a bunch of files in your repo, but specifically for GitHub Actions, you should be using a repo that's called .github with the subdirectory workflows. So within there, you should be adding these configuration files, these .yaml files. And this is what a YAML file can look like here on your right side. So what it's saying is essentially that if you try to push some code to this repo, then I will run a series of steps. And if I look at what steps, I see that the first step is checking out code. I see that it's going to be using another action here called setup node. And I also see that it's going to use an argument 14, that's the node version. And then it will run a step here, npm install -g. This is a global installation of a program called BAT. It's a tool. And the very last step as part of this job is to run the BATS executable itself, just to get some kind of output from this program. So great. We roughly understand that there's a series of steps that kicks off as the result of an event, and you define what that event is on the on keyword, third from the top. So I've actually prepared a little demo here that you can go to yourself. My user is softchris, so if you want to see this yourself and tinker with it or clone this repo, it's called MLOps -demo-ga. I've created 2 different YAML files as part of this GitHub workflows subdirectory. So a couple of things we're going to do is to make sure that we kick off a GitHub actions when we create a PR, also show how we can manually trigger things, and we will also show you how we could be triggering a GitHub actions because we merged the PR. So let's talk about this solution also before we go into kind of demo mode and start demoing things around. We have a README file. It's always nice to have a README as part of GitHub repo. We have a train.py that will train our model, but you will see as part of the sample repo, it doesn't do much, but I placed it there because you folks listening are probably used to a file like that existing. Requirements.txt, that's something we use in Python where we can specify various libraries that we need. Tests.py, this is a Python file containing tests that may run or not run. And then the MLOps part of all this is the 3 different workflow files: PR created, train and deploy, and manual. So let's actually go into GitHub and locate this repo so you can see for yourself how all of this goes together, because it's easy to talk about it, but it kind of sticks better if we actually do some examples with this. Great, so now we've gone into MLOps exercise. This is definitely a repo that you can clone or fork yourself. But let's just see what this one looks like. So now we have the workflows. This is the interesting part of our solution. We see that it has a pull request YAML. What it does here on the pull request is that when you create a pull request, this is going to kick off. You see that it has a number of steps here. So you see that it checks out the code, it sets up Python to a certain version, it installs all your dependencies within the requirements.txt, and then it tries to run PyTest and also install PyTest and PyTest coverage, and then it produces a report by running pytest test.py. Great, so let's check the other one. You see that this one is manual, and you can see that on the workflow dispatch. If you missed it in the first one, you see that it had a different on condition which says pull request. So this is an important lesson when working with GitHub and GitHub Actions. Please define what the reason is for this workflow to run. In this case, it's because a PR is being created, and in this case, it's because we manually dispatch this. That's what workflow dispatch stands for. Now, if you look at this, you see what it's going to do is to check out your code, set up Node with a certain version, install BAT, this library, and then run BAT. Right, so the very first thing you want to ensure is that your directory structure is correct. That's one thing you can notice here. It says solution GitHub workflows. It needs to be .github/workflow. So if you go in here, you can see that we have created test.yaml like so. If we want to kick that off with a workflow dispatch, we can. Then we go into actions, and now you can see how it shows up here, and we can kick it off. So we can delete previous runs like this if we wanted to. Delete this workflow run. And if we want to kick this off, we can do run workflow, like so. And we can see that it says this workflow was successfully requested. And we can see now that it took a second or two, but we definitely have a workflow triggered. So we can click into that and see what happens here. Click here to see more details. So you can see all the different steps defined in the workflow file. how it sets up the job, how it checks out the code, and we can see how far along it is. So set up job, it did a bunch of things. And you can see that it's actually already done because it's green, which is great news, right? We see that it was able to manually trigger our workflow, but of course, if we expected some kind of output from it, we want to see what happens if we call run but. It would answer you with the name of the application, with its version because of the -v flag. So now you hopefully understand how you manually kick off a workflow. That could be efficient, especially in the context of training a model, because that's maybe not something you want to do all the time. But if you instead have something a bit more practical, like a pull request like this. So we will take this. As I said before, this is not correctly placed. So what we want to do is create it in here instead. So we'll go here in workflows, just to say we want to add a file like this, and we will call it pull request.yaml. And now we can just paste our code that should trigger when a pull request is being created. And of course, there we are just committing on the main branch right now, which isn't ideal, right? But what we can do, if we go into, for example, not generate, but let's go into tests and fail that on purpose. So if we go in here and do def test like so and assert false, this should effectively break our test. So we can choose to commit that, but let's create a new branch and start a pull request, which ideally will then trigger this action. Adding a test. So we should always add some nice comments, and we create a pull request. And this ends up then running. You see now how it is running the pull request YAML file, and it's trying to see whether this introduced a good change or a bad change. A bad change would be one where it fails, and you see all checks have failed. Why is it failing? Well, we wanted the test to run, and you saw on the assertion false that this will definitely not happen. So what we can do instead to make sure that everything passes here is to go back here one level. Here you can just go back here and say assert true instead, which should mean now that our workflow should be happy. So now we add a single comment and we commit suggestion. So we commit this to the PR. But the way I've kind of created this, you're not actually going to see this properly or not. So I'm going to close this pull request. I'm going to reopen it. I think that's what's needed. Yeah, exactly. So if I close the pull request and I open it again, then it should react. So I would need to introduce other types of state to make sure that each change in the pull request is actually running this this pull request YAML. And now you can see why is our tests failing. That's an interesting one. What we can do then is to inspect and see why that is. This is the latest one. Let's see here now, 1 minute ago. This should be the one. Why are you failing? Check the code. It's failing on installing dependency. So this doesn't really have to do with the code, but it's still an interesting, error message, because we can have those issues sometime. So now it tells us that we should be using scikit-learn instead of sklearn. So that's a good lesson. We should definitely look into why that is. If you're using this, I think you knew this already, that sklearn was deprecated, but this is the great part of having a pipeline like this set up. So what we can do here is to edit this, I believe. now we go back to our pull requests, and yeah, because of the state of the triggering event, we just have to go in here and close it and open it, and it should kick off. So providing now that I have kind of fixed this issue, it should complain less as it's trying to install things. You see how the pull request kicks off again, and we can just go in here if we don't want to wait. So we go in, we check our code, and it's trying to install a bunch of different libraries. Did it try to install? Yeah, it installed the scikit-learn without any problem at all. So now it should, once it's done with it downloading and installing, it should run PyTests, and hopefully that also succeeds. No, it didn't. Why? Yeah, so I think I kind of proved my point though, why it's really good to have this, because, you know, it was able to detect issues, and now it's probably one of our tests that are failing, and once we fix those tests, then everything is happy days. But you can always find the end reason why something is failing by looking through the logs from a GitHub action. So you see the workflow that you need to have back and forth. And yeah, so this one is telling us that something is wrong here. But that's all fine. As I say, hopefully now you understand when things are triggered based on a condition on the on parameter or on. Let me just show you again so you know what I'm saying. So based on this, you can trigger this on virtually any event, right? Either you create a pull request, or you reopen it, or it's manually dispatched. So let's go back to our slides and let's try to bring this home. Let's talk about the Azure ML version of this. All right, so now that we've seen a simple example of using GitHub Actions on a fair amount of code, we saw how we can kick things off, but also how workflows can be triggered as the result of you, for example, creating pull request. So the question is, how do we automate Azure ML? Well, there are a couple of things that we need to know, and this is specific to Azure ML, or well, this first one isn't. With anything Azure, when you need to communicate with Azure, you need to make sure that you have some credentials that Azure is willing to accept. So a service principal is a bit like an API key. It's a secret that identifies you as you. In this case, it identifies me as Chris, and it says, yeah, Chris, I know you. I know that you got a cloud instance of Azure ML, and if you present me with this credential, I will let you in. I will use this instance that you have created. The other bit is the Azure ML executable. This is something that will help you create jobs. The very thing that you saw that you created visually on Azure ML, you can do that programmatically as well. Now for the first step, this is just some code that you can run inside of your terminal or in your Cloud Shell. This creates your service principal. Of course, you need to replace a few things here, like give this principal a decent name, maybe Azure ML my project. And you need to make sure that you also replace the name for the resource group. Once you have all that, it will spit out the secret that you can then use. Now, the important part, because we're now talking about the service principal, is that once you have it, you need to tuck this in as a secret in this key value store in the secret section of your GitHub repo. Once you've done that, you know for sure that you can refer to this within your YAML code and say, hey, you know this Azure secret here. Use this to identify me so that I can connect to my Azure instance. Once you have that, it will recognize you and will allow you to do whatever you need to do. Now, and here, for example, we have created this Azure credentials secret. The key's value name is called Azure credentials, and we pasted the service principal secret as its value. So if we refer to it like code like this, we will correctly identify ourselves toward Azure, and we're able to do whatever else we need to do. Now, the other bit of this is that we need to install an extension. If you don't have Azure CLI, the CLI tool for talking to Azure, you should install that first. Once you have that, you can call AC extension, and well, this command here that will install the extension needed for Azure ML. And then lastly, here's how you submit a job by calling Azure ML job create, and you give it a job a YML as input argument. So here's what that can look like. So if you were then to take your configuration file, your YAML file, in one of your run steps, then you can actually then call Azure ML job create with the file as a parameter, and you just specify which configuration file contains what you need to do to create a job. And here's what an entire configuration file can look like with everything included. So what we're looking at here is how you first check out your code in your very first step, then you install the extension and you add it. Then we try to log in towards Azure, that's now using our service principal, and lastly it's calling to create a job. So you can see how all of this comes together by you specifying everything that should happen as part of your configuration file. Now, so currently we trigger the job through a workflow dispatch. As I said, that might not be what you want to do. You might want it to trigger on a pull request, or maybe your code is being merged into your main branch. So what's a better trigger? What's a better trigger condition? Well, you want it on push, and this usually is triggered once you merge a PR. So you might want to switch from, let's just check, from workflow dispatch to on push. So that's just something to keep in mind. So what about a larger MLOps example? I mean, I bet you want to look at something way more meaty than this, right? Even if you start to get the hang of how to work with Git, GitHub, and even Azure ML, you probably want to look at a solution that contains all the things, and we will. So in this larger solution, we will do exactly what we said before. We will need to create a service principal that identifies us correctly. We will need to fork the repo if we're actually doing this. And we need to add the secrets to this fork so that we are correctly identified towards Azure. And then we might need to tweak the configuration file, and then manually kick off things. One of the things we might want to kick off is to create our cloud resources. Another one would deploy the model. So there are definitely cases where you want things to be kicked off based on merging code, and in other places you might actually want it manual. So only you know the answer to what things you want done manual versus automatic. But the end result is that some kind of flow completes, and it's able to create your cloud resources and train your model and deploy everything to the cloud. Right, so let me first take you here. This is quite a comprehensive demo for allowing you to work with MLOps with GitHub. I definitely recommend going through this tutorial from top to bottom, because it will take you through the exact journey that I mentioned to you. Everything from creating that service principal that identifies you towards Azure. Once you have that service principal, it guides you how to paste that as a GitHub secret. And it takes you through how to create the fork, and the secrets portion of this. Once you have that, that's great. And then it shows you how to deploy the project's infrastructure, all the cloud resources that you're going to need. That's also part of this project. And you might wonder what that project looks like that it refers to in the tutorial. This is what this project looked like, and hopefully you recognize yourself by now, because it has a .github subdirectory, and within there it has the workflow subdirectory. And if you just look specifically at the infrastructure, we see how that's a file that is going to use Terraform as deployment, and it will in turn use some kind of file here for deploying a bunch of infrastructure, and it uses various parameters, Azure credentials, ARM client, and whatever else it needs. But what's interesting to look at is that it refers to an infrastructure file, so we can definitely see how things are being created for us. So this is a good things to check out. You usually, whether it's Bicep or Terraform, you usually have a main file, and this main file tells you that things are about to happen. So the AML deploy file is where the interesting stuff happens. It refers to various modules, so a resource group, our logical bucket, our workspace that you saw that we created manually in the visual interface, a storage account because we need to store our file somewhere, a key vault because we want to store our secret in there, application insights because we want to store metrics around this deployment, container registry if we can create this as some kind of Docker container and we want to push the container in there, and some kind of data explorer. So we see that everything that we could possibly need to work with this example is included in here. And if you want to see what a specific resource, how it's encoded, you can always go in here and look here. And the resource keyword is what is significant for defining a cloud resource. So everything is in here. I definitely recommend going through this tutorial and kick things off. And let's just see that this is manually kicked off. So because this is just something that you run the very first time you're dealing with cloud resources, this is a one-off. So it makes sense for this to be manual. If we look at deployment steps, it's the same thing there. They are manual. But as I said, if you are trying to change code and if you want tests to run, you probably want a workflow that is specifically triggered on a pull request, which I showed you in an earlier demo. But definitely go through all these. Hopefully you have now a sharper eyes so that you're able to understand why it's being triggered and all the various steps that happens throughout the job. So let's go back to our PowerPoint, because now we are rounding up our talk. We went through quite a few different things today, but my idea was to present you with MLOps, what is MLOps, and also to show you how you can do things visually in Azure ML. That's great, but if you want to take it full on and completely automate all the things, you need to be looking at GitHub Actions, how you can identify yourself towards Azure with a service principal, and how you can define these workflow files for testing your code, for deploying cloud infrastructure, for kicking off model training, and so on. This is a really great approach for automating all the things with machine learning and MLOps. Thank you so much for watching. My name is Chris Noring, and I hope I see you in a future video. Bye now.